How's everyone? Oh, I got the end of the screen up right there. We just finished the BAS 320. Good to see you here, Philip. Good to see you here, Jesse. Good to see you here, Sheena. Good to see you here, Madison. Good to see you here, Caroline. Let's try a little chill music. Got some 16-bit music. Good to see you here, McKenna. Good to see you here. Who else we got? Grant and Philip and Abby and Adeline right there, and Gage and Derek and Martin. Who else is in the chat? Good to see you there. Sarah and Elizabeth and Seth and Chandler and Adeline again. And Lane right there. Meredith, good to see you. Woo, says Lane. Join in the Kahoot. The Kahoot code is at the top. Harrison, good to see you. How was the earlier review? It was pretty good. You can check out their review if you want. See what we do in 320. We went over a lot of output and interpretations. So we only had 17 questions for them because the main focus of it was like, how do we interpret this? What does it mean? What would we tell someone? They only have on their test 10 questions, and they're all written. What are your thoughts on that as we listen to more 32-bit music? We'll put a 2-minute timer on, then we'll get started so we don't get started too late here. But join in. They have 10 questions that are interpretations. That's their whole test. Got pointers in the chat. You have 4 interpretations. Interesting, right? Back in Nashville, Philip, that's awesome. Nashville's got some good stuff, like what is it? Cow and Cork? Then Cork and Cow, I think it's called. It's a good place. Check out Cork and Cow if they're still around. You got Frothy Monkey. I'm going to get 0.72 of a tattoo. Putting those quotes in the chat right there. Someone said that in Stat one time. Hey, Jacqueline, good to see you here. Can we get 100 players? Drivers have been making angry. I'm sorry about that. Go downtown. Walk downtown. Go there early and get the Pancake Factory. Gotta get there really early because that place is crowded. Doesn't sound like a fun task, but some of their pictures come straight from the notes. So if you follow along with the notes, some of their pictures on their test that say interpret this, I did half of their pictures are new pictures, half the pictures are from the notes. The Pancake Pantry is awesome, right? Really good place downtown. Then there's another place. If you walk up from the Pancake Pantry over to the right, it's got like a little wraparound or something. Really good place there too. So anyone remember what that's called? My wife and I went there. Yeah, not too bad then, right? So you've got new output and old output, and it's all output they've seen. So it's all output like you've seen pictures like this before. Now you tell me what it means. Because that's what we do. We interpret, we give context to things, and we talk about utilizing it. Join in. Let's see if we can get 100. Code's at the top. I'm going to give it one more 2-minute, and then we are going to start. So if you're worried, if your phone's all waiting right now, 2 minutes, 115 seconds right now, we'll get started. What's your favorite restaurant where you're at? If you want, name your favorite restaurant. In Knoxville, for me, it was Taste of Thai. I still love Stock and Barrel, Soccer Taco, and also Hard Knocks Pizza. Like McDonald's got some good stuff. I'm sorry, but every once in a while, a Big Mac, cheese, P.F. Chang's is good. P.F. Chang's is some good stuff. Like P.F. Chang's, anyone watch Red and Link, Good Mythical Morning? It's so funny, like, they actually liked some Taco Bell stuff. I think Taco Bell and P.F. Chang's have both been some like good stuff right there. Stock and Barrel, get the Bernie at Stock and Barrel. It's like got fried jalapenos with I think blue cheese and blueberry sauce. Sticky rice is some good stuff. Chivo's, however it's pronounced, downtown is good stuff. Nama's good stuff. Downtown Nama. What's your Sonic drink order? They've got like a Oreo cheesecake milkshake. That's good stuff right there, Kristen. McKenna's? Where's that at? I don't know that one. Vita Seagun Fire. That sounds really good, Abish. Where's that at, Abish? Is that Knoxville? And what kind of food is it? Sounds really good. Chayo's in the fort is really good. Chayo's is top tier. Been to Sushi. That sounds really good, Galen. Getting started here in 35 seconds. They brought back the Red Bull Slushie. Ooh. Kingston? What about some, why can't I think of the name of it? Gosh, I can't think of the name of it. Pals. Everyone likes Pals. Hibachi. It's off Kingston Pike. It's a hibachi and sushi. That's really good. Vita Saigon is Vietnamese. Ooh, I don't think I've had that. I've been to Gosh Ethiopian. There's an Ethiopian place in Knoxville. There was. It was pretty good. Like, I think I'm not that big into vegetarian food, and Ethiopian food's more vegetarian. So I think that's why I was like, yeah, it's okay. Like, it was good, but it was, like Hard Knocks, Taste of Thai, Soccer Taco, Stock and Barrel. I've been to Ethiopian. Plum Tree's pretty good. Well, that's got it. Food talk over. It's time for some review of statistics. I need some I'm ready's in the chat. Who's ready here? I wasn't a huge fan of the food. All right. Popita? That sounds good, SP Ball. I need some I'm ready's in the chat. Give me some I'm ready. I'm ready. Woo! Can't sing. We love food talk. I love food talk too. So let's do this right here in 3, 2, 1. Let's Kahoot. Here we go. Get ready. First question is 3, 2, 1. More of an intro. First question is, we would use what test to see if there's a relationship between being married and a student's age? Now, this is kind of a tools and techniques question right here. So you think about which kind of test would we use? Now, when you're doing tools and techniques, what's the number one thing to be thinking about? And I've given you hints right here. You might not get those hints on the test. When doing tools and techniques, the number one thing to be thinking about is what's. Is this cat? Is this quant? So when you look at this right here, we might want to understand people's age, meaning it's the Y variable of interest, with whether they're married or not. Married or not has what to it. So if you've already answered, try to like work through this with me. And then if you haven't answered, watch this again. You'll hear me explaining it. So we figured out married is categorical and married has what to it. Married has, it's a yes, no answer, 2 levels, right? It's binomial, it's 2 levels. So you're going to compare the 2 groups. And since age is quantitative, that means for certain you're looking at a what? So since age is quantitative, so how could you narrow this down? Age being quantitative can eliminate a few things right here. Great job. Age being quantitative means T, right? And the 2 sample T would be used to compare the what's between 2 groups. So the 2 sample T is used when what? Great job, Maya, right there. Good answers. Let's throw 1,000 points out. The 2 sample T is used to compare the means, great job, Elizabeth, of 2 groups. And the chi-squared would be used when what? When do we use chi-squared? So don't worry if you got it wrong. Chi-squared is used when what? And so take these notes if you don't have them. And we got great stuff from Sloan right there too. Chi-squared is used when we have 2 categorical variables. The 1 sample T would be a question like, let's analyze people's age because that's 1 sample. And the 1 proportion Z would be like, let's analyze the proportion of married people. So good work right here on this question. Pretty good answers. Proportions are for what variables only though? And it's for 1 proportion. Like let's look at the proportion of who's married. Proportions are only for what? For categorical. And then as soon as you see something as quantitative, if we're trying to analyze that, you're going to go towards a T test. So that's the trick right there. So let's see who's on the leaderboard. Decisive New, I think that's how you say that. Mighty Rabbit. Oh my gosh, Mighty Rabbit. No way. Did I just remove that person? Okay. Mighty Rabbit. I'm giving you first, second, third, get $20 Amazon gift cards. Mighty Rabbit, I want you to rejoin, and you've automatically won a $20 gift card. Who's Mighty Rabbit? Was that you, Sloan? If it's you, Sloan, I'm almost kind of happy because I feel like everyone knows Sloan. I would never do that to you. Not that I would do it to anyone else. Was that you, Sloan? I can't believe. I like hovered over it and I clicked and I didn't know it would delete you. It was Sloan. You just won a $20 Amazon gift card. Sloan, have you joined back in? I thought it was the coolest name ever because everyone knows I love rabbits. And I promise on it. There you go. Well, Sloan, have you joined back in? Okay. I'm working on it. Okay, Sloan, tell me yes, you're back in. We'll get you back in here, Sloan. And then Sloan, I cannot believe that. I've never done that. I've done Kahoots for 5-6 years and I've never clicked on someone. Okay. Well, thank you, Sloan, for not being mad at me. We're not going to click on anyone's names anymore, even though Rockstar Hair is pretty awesome. Also a rabbit right there. Let's go on to the next question before Brian makes more mistakes. Here we go. How can we test the relationship between someone owning a pet and if they are married? I think Sloan gave some really helpful hints on this. Once again, the tools and techniques questions are going to be related to what are the variable types. Thank you, Sloan, right there for not being mad. You are a winner already, Sloan, because Brian made a mistake. I was like going to highlight your name. No, why would they even allow that? It should have a confirmation. So tools and techniques, The number one thing, and I'm not blocking any right answers, hints if you've already not answered. The number one thing with tools and techniques is to figure out the types of what's. The number one thing with tools and techniques is to figure out the types of what's. Or I did it for you here. It's probably not going to be on the test. The variable types. So what graphic would you make with this? What graphic would you use to look at someone owning a pet and if they're married? So you could then see kind of the proportions, but what graphic, I'm not saying it, but I'm kind of showing it to you. Mosaic plot. If you can kind of see, I'm talking about like maybe someone's more likely to own a pet if they're married, which kind of makes sense. Like, you know, if you're married, you might have a house, you're older, like, you know, you're not usually married like at 17, 18, 19, 20. Then you can get married, but you're more likely to be married at older, and you might be more likely. So there might be a lurking variable like age, which is quantitative, different analysis there. But we could do the mosaic plot, contingency table to look at this, and then the chi-square test of independence would tell us. Does anyone know the null hypothesis right here? For owning a pet and being married, the null hypothesis would be what? So we're doing a lot of review right here because this is the chi-square test of independence. So what would be the null hypothesis for owning a pet and being married? So what would be their independent, right, Sarah? So we want to write the full thing out. And we got to throw 1,000 points right there. And I think Maya did it perfectly. Owning a pet and being married are independent. Owning a pet is independent of being married, as in it doesn't really tell you anything. Great work right there. Chi-square test of independence is one of the best ones for just writing it out. We have a lot of practice problems on solving some of the notation. Who's in the lead right here? We see Decisive New and Bold Leopard and Dazzled Panda. I'm not going to hover over anyone's names. Let's give everyone $20 Amazon gift cards. Good work right there, Shina, and great work. Here's the next question. Let's do it. When doing a hypothesis test on the mean, which is a condition that must be met? Hypothesis test on the mean. It's a really good question. These are all the conditions that are beyond random and 10%. Random and 10% are the conditions we always have for test 3 when we do like the proportion interval or mean interval or 2 sample t interval. You'll always do random, meaning the data was randomly collected, and 10%, meaning we collected less than 10% of the population. It's more complex, and I did do a video talking about what the 10% condition means, but let's focus on the last remaining conditions. Now, when you get to the remaining conditions, sometimes we have 4 conditions, and sometimes we have 3 conditions. So the way to know there's 3 conditions, and good work right there. Now, a lot of people said success failure. How do you know? You're going to get back on the podium, Sloan. Make it happen. How do you know when to use success failure or nearly normal? Let's actually write on this. I'm going to take a screenshot here and write on this. How do you know success failure or nearly normal? How do you know success failure? Take a screenshot here and show you. So we're taking notes right here. Great work right there, Jesse. Throw some points here in a second. Okay, so nearly normal is quant y. And success failure is cat y. Count data and cell. When are these used over here? Expected cell count and count data are for what? Great answers in the chat. When do we use those conditions? When do we use those conditions right there? Really good practice in the chat. Chi-squared. Lane said perfectly, and so did Jesse right there. These are chi-squared. Those are conditions 3 and 4 for chi-squared when you do the chi-squared test of independence. So if we go right here, when do we use the nearly normal condition? What tests or intervals use the nearly normal condition as condition 3? So the nearly normal condition will be used when? You can kind of just sum it up with these. But there's the 1 version and the 2 version, the tests and the interval versions. The nearly normal condition will be used when what? 1 sample, 2 sample. Great job, Brianna, right there. Perfect. The T's. Yep. 1 sample T, 2 sample T, all things like that. I'm going to throw some points in a second. But the 1 sample T, like interval or test, 1 sample T, 2 sample T, test or interval, they're kind of interchangeable. And then down here, this is going to be a 1 proportion Z. So that's when we do proportions right there. And then there's the chi-squared over there, which is the test. Now, the 2 sample T does have with it an additional condition. What is the final condition for the 2 sample T? And we've actually reviewed all the conditions on this screen. So there's the tests in green. We're saying that the chi-squared is the test itself, and the chi-squared is 2 categorical variables, which is literally the condition count data. Independent groups. Wow, great job, everybody.
Wow.
Good work. So with this, we have the 2 sample T actually has the independence condition 2, meaning the means are independent. One mean does not influence the other mean. So really good work. Write down all these conditions right here. Also check out, if you didn't know this, and I'll show it here on the screen. Here we'll go to review 3. I do want to point this out. Has anyone been watching? Wow. Has anyone been watching any of the review videos here as you've been working away? Has anyone been watching any of the review videos? And I highly suggest, if they load in, the playlist I have, if they'll load, yes, good stuff. I have a playlist of the concept reviews. Don't know why it's not loading today. It should load. Go to the concept review videos, watch the concept reviews. I'll try to show them here later in the speedruns, concept reviews, and take notes while you're doing it. In the concept review video, I do walk through, and I don't know why it's loading. We'll give one more try here. Gonna load. Gonna show me my videos. And maybe we'll come back to it. Okay, we'll try it later. Go into that leaderboard. Let's see how they're doing here on the leaderboard. Boom! Classy glider jumping up right there. Bold leopard and decisive new. Let's see who's going to win. Speedruns our lifestyle. Thank you, Vaughn, right there. Appreciate that. Here we go with the next question. What condition do we need at least 5 of? So there's a little bit of review right here. This is a chi-squared condition that we need at least 5 of. We'll be doing some calculations on this later. So if you want to review the conditions right here, remember, on the chi-squared test of independence, we have 4 conditions. Condition 1 and condition 2 are always the easiest ones because they're the same. Random. We randomly select the data. 10%. The data is less than 10% of the total population. Pause. Okay, we're doing the chi-squared test of independence. We'll jump to condition 4 for the moment. Condition 4, there is no order to these, but I call it condition 4 is count data, which means both variables are categorical, which to do the chi-squared, you literally have to have. But the one that we need at least 5 of is at least 5 expected cell counts. At least 5 expected. So, oh, you got this on the projector in the library. What's up, library people? Good to see you here. And success failures for proportion tests. We need at least 10 successes, at least 10 failures. That's for one categorical Y variable. And nearly normal is when we do the T tests, and we need the data to be nearly normal for both distributions if we have a 2 sample T. Good work right there. We'll be doing some calculations on expected cell count. Put it this way. 1,000 people show up to your party. 10% of them are jocks, and 10% of them brought pizza. How many jocks would you expect to bring pizza? Jocks like Brian's a jock. I don't know. I don't know. I'm not. I don't know. I had someone think that I was that in high school. So if there's 1,000 people show up to your party, there's 1,000 people at your party. You're throwing this huge party. 10% of them are athletes, and 10% brought pizza. Then what percent would you expect to be athletes who brought pizza? Is that right? Yeah, I think it is, right? Caitlin, great job, Caitlin, right there. Austin, thank you. Well, think if there's 100, if 10% are athletes, 10% brought pizza, then think about it mathematically, like the rule we use, then you'd expect 1% of them to be athletes and bring pizza. That's actually the math we do. We'll show some of the ways of doing this. It should be 10 though. So if 100 people are athletes and 10% of people brought pizza, then we'd expect 10% of the 100 athletes to bring pizza. Who thinks, I'm wondering if people understand that. Yes or no, really quickly, did you understand that example? Does that kind of make sense? If you're like, 1,000 people show up to my party, 10% of them are jocks, athletes, and 10% brought pizza. So we're doing pretty good. You get it now? Then you would expect 100 of them to be athletes. And of the 100 athletes, Caitlin's showing some really good mathematics right there. Caitlin's explaining it mathematically. Then you would expect 10% of the 100 athletes to bring pizza. Now, that might not be what you see in the data, and that's what we call the observed. But the expected is just a mathematical calculation to say, well, if 10% of people are athletes and 10% of people brought pizza, and I have 1,000 pizza, I would expect 10 people to be athletes and bring pizza. So, yeah, the more you hear it, the more it might make sense. So we'll do more calculations on this later, but that's what the expected cell count is, and we do have at least 10 expected cell count right there, so we'd pass it. Or at least 5, excuse me, we had 10. Ooh, we got a bouncing around the leaderboard, bold leopard in the lead. Here we go with the next question. Which of the following must be met for the chi-squared test of independence? Is it a multi-select? Which of the following must be met for the chi-squared test of independence? I think it has multiple right answers. A lot of review over the same stuff right now. We will be doing different types of things, but just kind of hammering down the topics. Remember, the test you are doing determines the conditions you are using. The test you are doing determines the conditions you're using. 1,000 points. If anyone wants to put in the chat, thank you, Jack, for asking. So who wants to put in the chat where you can find the review, the formula sheet for test 3? Great job, Sloan. And thank you, Jesse. 1,000 points in the chat. Right there, review sheets can be found on review 3. Yep, review 3 right there. Good stuff. Thank you so much, Jack, for asking. You bought spam in review 3. To review again, nearly normal is when we have a quantitative Y, t-test, 2-sample t-test. Count data is for chi-squared, expected cell count is chi-squared, and success failure is for categorical, like proportions and testing a proportion. So the 2 answers are right there. Good work, and people are getting it down. They're edited on at the end of the semester. Is the review really similar? Pretty similar. Pretty similar. Remember, it's on Proctorio, and the best way to know what the test looks like is your Canvas content. We'll be going over a lot of things that could be on the test, and I promise you, people have told me, has anyone seen anything we do on the Kahoot virtually or identically on the test? Have you seen stuff? Because maybe that's why you're here. Have you seen stuff in these Kahoots that is like the test questions? We'll go to leaderboard. I would say yes. Well, oh, wait. Leaderboard, are you done? The chi-squared test statistic is found how? I'm disappearing. I thought did I not see the leaderboard? Chi-squared test statistic is found how? So what you have right here is the chi-squared test statistic of 0.338. Thank you so much, Kaylin, right there. And here is the p-value telling us that it is not statistically significant. And here's what to remember. The Pearson has your p-value. This is the chi-squared test statistic right here. Everything else, it doesn't matter. Really, when you look at this output, I'm going to take another screenshot and make sure it's very clear. Sorry, I'm blocking the screen right there, but I want you to know that in this output, the only things that really matter are this and this. That's all that matters. And what you have right here is this tells you it is statistically significant, and it's not because the p-value is above 0.05, so this is not, we would not reject the null. And then over here, this value is the sum of all the cell chi-squareds. That's what we would have right here. The chi-squared test statistic is found by taking the sum of all the cell chi-squareds. We're able to make the threshold. We did get the +2. We didn't get the +3. Huge shout outs. So good job right there. We did get the +2. We didn't get the +3 for both classes. We got like 85 and 82%. Really good job. 90% is really tough, and I'm really proud of the +2 right there. Yeah, the +3 is really hard to get. I almost feel bad, like we should do 85%, but we do the same for every class, so I can't change the standard, or else another class will be like, wait a minute, a high p-value means it isn't. Great job, Sheena, right there. That is correct. When is a p-value statistically significant? That one is not statistically significant, and why? I can't, Austin. I don't have that power. Only Terry has that power. Don't tell Terry to change it. When is that? Why is that p-value not statistically significant? It's above 0.05. So we like to say when the p-value is low, reject the null. When the p-value is high, just let it fly. When the p-value is lower than alpha, and without stating it, alpha is assumed to be 0.05, and with any reasonable level of alpha, we would not reject this. Great job, Meredith, right there, and Sarah. Then we do not have evidence of a relationship, or do not have evidence that they're not independent. So this is a very high p-value, and look how it says prob, because what are p-values? P-values are the what of our result or result more extreme happening by random chance variation given that the null is true. A p-value is the what of our result or results more extreme happening by random chance variation. Probability, great job, Austin, right there. It's the probability, and that's where it goes to the interpretation. What is the probability of getting a chi-squared this extreme or more? That's why it says the probability of something at this or greater. So you could do technically equal to, but goes to math, how there's really not anything above it. And good work. That's a much deeper understanding, but that is the p-value. It's high, so we'd let the null fly. We just let it be. We do not reject the null right there. It is not statistically significant. Leaderboard. Epic Crane jumping up there, but Bold Leopard in the lead. Are you back on the leaderboard, Sloan? I'll be excited if you are. That'd be great. Here we go with the next question. Let's do it. I'm only rooting for Sloan because I knocked him out of the leaderboard. What is your decision regarding the null? Now, there's some words we do not use right here. What is a word that you would not say that if it's on the test anywhere, you would just be like, nope? What word on this screen is something you're like, nope, not going to click that button? Except. We don't talk about except. We either reject or fail to reject the null. We either reject or fail to reject the null. Now, if you're wondering about the wording of fail to reject, I like to phrase it this way. You either go to the mall or you fail to go to the mall. If you fail to go to the mall, what are you telling someone? If you fail to go to the mall, great job, Emma, right there. P-value low, reject the null. Yep, that'll answer this question. If you fail to go to the mall, what are you telling somebody? If you failed to go to the mall, it's the same thing. You didn't go, right? Kaylin's, so that's when we say we fail to reject the null. That means you don't reject. It's a weird way of saying it. I do agree. So you'll sometimes hear me say I don't reject the null. And why don't we reject the null here? Well, just easy way to remember. When the p-value is high, just let the null what? And that's the p-value. When the p-value is high, just let the null what? If the p-value is low, reject the null. If the p-value is higher than 0.05, assumed to be alpha, just let it fly. Just let it be. Don't reject it. That's what let it fly means. So when the p-value is low, reject the null. When the p-value is high, just let it fly. Just let it be. Don't reject that. And if you want to think about how this, like what this means, I do like to talk about like what this means for a second. Think about this. When would we have a high or low p-value? If Brian told you, and I told a student this one time, I said, I can run a 6-minute mile. So the student says, let's go out to the track. I told them this when I was like 30. And so here's Brian. And Brian goes out to the track and he runs around it. Apparently I'm a giant. You know, Attack on Titan right here. And my time on average was equal to this. Now my claim was that. Now, does my time right here, I know, well, I don't think I could do it nowadays. Does what you saw me do seem likely or unlikely given the null is true? You saw me run it in like about a second more. Like that's not, if you think about it, it's actually less than a second. Like I was less than a second away. So when you graph this mathematically, and we're not doing the full test right here, it's going to look like this right here. This is just an idea of it. Here's where 6 minutes is at. And I would be right here because my result is a what result if I am a 6-minute mile runner? Think about why the p-value is high. Now, this is not me doing the math. It's just talking about what a p-value is. What you saw me do was what, given I am a 6-minute mile runner. The what you saw me do is the 6.01, my sample average mile time. Here's my claim, and what there's the claim at the center, and here's the result. What you saw me do right here at 6.01 was likely given the null is true. But what if I were to do the following and take 8 minutes? Now you're probably going to what? So Brian says he can run 6-minute miles on average. And now I'm all the way over here. And now this result seems what if I'm a 6-minute mile runner? If Brian is a 6-minute mile runner, this result of 8 minutes, 0.01 technically, looks very, very what? That result right there, if I am a 6-minute mile runner, me running 8-minute miles seems very, very what? Unlikely. So what would you do? Just think, don't even think statistics right here. Don't even talk to me like it's stats. If I say I can run my miles in 6 minutes on average, and you go out and watch me run around the track, and I'm taking 8 minutes, and I'm like, "Whoo, that was some good times. How'd I do?" And you're like, "Yeah, you took about 8 minutes on average." So you're saying reject it, right? So what does that mean? You would say, Brian, I don't believe you're a 6-minute mile runner. I've got evidence to show you're not. Like I don't think you can do that. Look at your mile times. Does that make sense why we talk about like we reject the claim? We have evidence for the alternative that probably you take more than 6 minutes. So there'd be strong evidence in this case. I did it as the greater than test. And can anyone say briefly right here, how do you know I did this as the greater than test? Who can look at that visually down below and be like, yep, Brian was running the greater than alternative? Who can look at that and be like, oh yeah, you did a greater than alternative when you test this. So I tested the null hypothesis is Brian's true mean mile times is 6 minute. The alternative is that it greater than 6. Shaded to the right. The direction by which you shade to the right, to the left is indicative of the sign of the alternative. It's just on a right side. If you shade the lower half, it'd be the left, less than curve. If you shade both sides, it's the does not equals. So you could run the does not equals and you could double the p-value. So really good stuff right there. Lots of review. Let's see who's on the leaderboard right here. Good work. Great Dragon, good to see you here. Next question, let's do it. How many degrees of freedom does this test have? Why did I give this 90 seconds? Well, let's talk about degrees of freedom then. Okay, there are 3 times we use degrees of freedom. The first time we talked about degrees of freedom was for the what? And I'm giving you a hint right here. The first time we talked about degrees of freedom, so work through this with me if you've already answered. The first time we talked about degrees of freedom was for the what? The one sample t. And we can do it with tests or interval for the one sample t. And Emma has it right there. It's n minus 1. So the one sample t, when you're just testing like the age of people, one quantitative variable, one sample t, n minus 1. Now, the second time we did degrees of freedom is when we were talking about the what. So you can kind of help memorize it this way. The second time we talked about degrees of freedom was for the what? Emma's got the third. The second time we talked about degrees of freedom was for the what? First time was the one sample t. Second time, Vaughn, great. I'm making Vaughn a mod. Second time was the two sample t. Great work, Vaughn, right there, answering tons of questions. And so it was the two sample t. And the two sample t has a formula that Maya said right there perfectly is too complicated. We don't solve that one by hand. We go to applets and stuff to solve it, or output will show it. Now, next, think about this, we do the chi-squared. And this is a 2 by 2. So what is the mathematical formula to figure out the degrees of freedom for this one? Well, the answer is also on the screen. Rose -1. Sheena, great job right there. And wow, I'm throwing some 5,000 points for all those amazing answers. We had so many people get it right. And so here's what you got to say to me. Brian, this is a 2 by 2. So the formula is going to be, and Abby has it right there, 1 times 1. Great job, people writing it out. Rose -1 times Collins -1, 2 by 2, delete, 1 times 1, delete. So great work right there, reviewing degrees of freedom and understanding how they work. Just remember, walk through that. The 3 times we've used degrees of freedom: 1 sample t, 2 sample t, chi-squared, and good practice right there. Next question, leaderboard first though. Ooh, it's locked up. Bold Leopard in the lead. Here we go. What is the null for this test? A lot of chi-squared. And the easiest way to do the null, whenever you're doing, I think we switch off of chi-squared here coming up in half a second. Type 1, type 2 errors towards the end. What is the one word you need to remember for the chi-squared test of independence? And let's talk about what that means. The chi-squared test of independence. You want to go, and great job right there in the chat. You want to go right here to your output. If you're remembering how to write this, we used to have you write out more often on the test. Take your 2 words, gender, breaking a bone, go between them, and put the word independent. What does it mean if 2 things are independent? Like if I told you somebody's gender is independent of them breaking a bone, this blue answer right there, what would it mean if I told you they're independent? Like, what am I communicating to you there? There's no relationship. Knowing one would tell you nothing about the other. That if you knew someone's gender, it would tell you nothing about the probability of them breaking a bone. Now look at the nature of the association. Males might be what right here? It is a statistically significant association, which we would reject the null for. Now the nature of the association is what? Are we? I don't think so. It's Kahoot music. I've done these before. Never gotten copyright claimed on the, well, I did on something else, but then I got it taken down. What is the nature? Does anyone know the nature of the association? So look at the graphic right here. Oh, they know. No worries, Sloan. Who can explain the nature of the association? Who can explain the nature of it? Like, what's going on with the association up here? So this is, have you broken a bone? Yes or no. Gender, male, female. So what's the nature of the association? What is it telling us? It is a statistically significant association that's unlikely by random chance via the low p-value. We have evidence that they're not independent. Well, so we have evidence that breaking a bone and gender are not independent. So we do have evidence right here. We reject the null that gender and breaking a bone are not that they are independent. We have evidence they're not independent. And the nature of the association is males are more likely to break bones. It doesn't mean if you're male, you're going to break bones. It just means males are more likely to break bones. That's what we see right there. But most people have a 50-50 probability. If you look, females are about 45, males are about 55. If you hover over it. Oh, good job, Caitlin. Thank you so much for playing along right here. And it's for watching later too. Let's go to leaderboard. Yes, the more they don't line up, great job, Sloan, right there. The more they don't line up, the bigger the discrepancies, the bigger the association. Good work there on the chi-squared. I think we're switching off. Well, no, we're going to do some calculations here coming up in a moment. So get ready. Have your calculator out, but first a multi-select. What is the alternative for the test? So I do love this being a multi-select right here because I do want to illustrate that we don't just want to memorize things, we want to understand what we're saying. So when we reject the null, it means, well, the null is that they are independent. So when you reject the null, what are you saying? Think about what phrases would make sense when you reject the null right here. Really good question, Emma, that breaks into this. If you reject the null here, which you do, you're rejecting that these two are independent. So when you're rejecting the null, you're saying you have evidence what? Which of these phrases would make sense to say you have evidence for? So that's a good question right here. So which of these phrases would make sense? Which phrases would be good? If you reject the null, you're saying, I have evidence what? Of a what? What do people think? This is where you might have to write it out. You would say, I reject the null. I have evidence gender is associated with breaking a bone. And that's also the same thing as saying not independent. Because not independent means that we have evidence of an association. Like if they are independent, there is no association. The two right things here we could say are, I reject the null, that these two things are independent. I have evidence that gender and breaking a bone are associated. Or I have evidence that gender and breaking a bone are not independent. You could say dependent, that somebody breaking a bone would be dependent on gender. But that doesn't mean if you are a gender, you will break a bone. It just means knowing somebody's gender would give you information. Good work right there. I think we're going to do, so have your calculator out. Grab a calculator if you don't have it. Or do some quick math on paper, but you will need a calculator for the test. Let's go take a look at the upcoming questions. We're towards those. Aquatic bison, good to see you here. Find the missing value. Calculator time. Get ready. Okay, so what are you calculating right here? What value are you calculating right here? So some people might be working through this right now, but if you're not, or if you've done it, what value are you calculating? We talked about this earlier. The expected, great job, Kristen, right there. The expected value is what is being calculated. The count is the top one. The count represents there's 163 females who were not born in Tennessee. Right here, 128 males are not born in Tennessee, and this is the total of people not born in Tennessee. This is the total of females right here. Now, the expected is a formula. And let's take a screenshot right here and solve the formula. You do get a formula sheet for the test, and the formula for the expected is what? I don't want to block the answers. Does anyone know it? It is row total times column total, grand total. Great job, Sloan, right there. Oh no, Philip. So the row total, column total, and right here, and grand total. Go. So solve this out. There we go. Whatever that solves to. Oh, Maya did it the quick way. I got to throw 1,000 points to Maya right there. Maya, did you do a double check? I got to throw, that's so good, the quick solve. So what Maya's pointing out is that if you look at this right here, or Maya might have done it another way. If you take these values right here, this plus this has to equal what? Like these two values added up have to equal that. So you can actually just do it that way right there. So that's an alternative solve. Only if you know the first solve would I suggest working the alternative solve. But when you add it up, yeah, exactly. Did you just see that, Maya? That is a great alternative solve. Or you could figure out what adds up to 770. That's another alternative solve. Only if you have the values, though, would you be able to do that. But Maya, we're throwing you another 1,000 points. Really great solve and a great way to double check your work if you understand how the table should add up. Excellent job right there. Continuing on, in the leaderboard, we have Great Dragon back on here, but we got Bold Leopard and Epic Crane and Wonder Kitten and Fuzzy Dingo, and I'm not allowed to hover over names. Here we go with the next question. Let's check it out. Find the missing value again. So for this one right here, you are finding a what? For this problem, you are finding a what? What are you finding? So first off, what are you finding? You're finding this value right here, but what is that value? Are you? You're back up there? Sloan, great job. What are you finding? Not the p-value. Good answer, Will, right there. We'll throw Will 1,000 points. We get points for all the answers. Not a p-value, though. That's not a p-value, though. Cell chi-squared. Great job, Abby, right there. Being Abby mod 2. So you're finding a cell chi-squared. So 1 second right here. Sorry, I got a blank screen because I do have the answer. If I show the answer here, you'll get to see the output again in just a second. Output back on the screen. So the cell chi-squared formula is observed minus expected squared over expected. But where is the observed on here? Where is the observed? Where is the observed? Because the expected is 131.895. It's a count. Yep. There it is. So that's about 416. It's going to be a very small decimal. Maybe that one. Yeah, there we go. So double check your work. Let's see. Hopefully a lot of people got it. But if you solve this formula right here that we have on the screen, 131.895, square that, divide by 131.895, and there it is right there. Pretty good work. A lot of people, remember, it's going to be observed minus expected squared over expected. And so knowing how to solve these, knowing what you're looking for, and knowing what the output's showing you is key. So here's all the work right here to get it. The observed is the count, which shows how many individuals there are. It's the frequency. It's the observed. It's how many there are. Good work right there. Tricky question. If you're getting it wrong, make sure to practice it and review these problems. Ooh, and you said you're Fuzzy Dingo? That's awesome right there. So we got Bold Leopard in the lead, Epic Crane, and Wonder Kid and Fuzzy Dingo. Great Dragon, great job. And everyone else, keep up the great work. What are the degrees of freedom for the one sample t interval? I think there's going to be some fast answers here. And why are the answers here so fast? Sloan said it right there. Great job, Sloan, right there. And really good practice. Let's throw 1,000 points right there for the practice and the answers. It's n-1. Easy one to memorize right there. n-1. It is on the formula sheet too. It's n-1. And n is sample size. n-1. Easy. Right there. 770. So it's going to be 769. When do we have it's a too complicated formula? So I'm going to ask just a few more questions on this. When is it the too complicated formula? When is it the too complicated formula for the degrees of freedom? When it's the 2 sample t. Like, when would we run a 2 sample t? If we were doing what? So this is my last. I'm going to throw 5,000 points. I want some big answers to this, though. When do we run the 2 sample t? It's a much more detailed question than a short answer. So for 5,000 points, when do we run the 2 sample t? Oh, no, did Philip? What happened? Oh, you were trying to click the answer on my screen. Mr. G is mean if you're doing drugs. Comparing means. Give me an example. Good job right there. Well, these are great. Okay, 5,000 points. That is the theoretical answer. What kind of test would we compare 2 means with? And great job, Kendall, right there too. Used to compare the means of 2 groups. Great job. And then what kind of data, when would we do this? Right in Kendall's a month. Thank you so much, everyone, being here and practicing. Well, so Amelia specifically, it's one quantitative, one categorical variable, and then the categorical variable has 2 levels. So it is 2 variables, one cat, one quant. So when would you do it? Comparing what? Give me an example of if we were, but it's not 2 categorical variables though. It is specifically, and I'll draw it out right here, married or not. Lane. Yes. Lane using, I'll give you the 5,000 points about Lane because that is the example I use. So it is the right answer. So the way it looks is there's a variable down here. You can do it like a yes, no variable as great job right there, Vaughn put. You have here a yes group and a no group, which is fine, or a married or not married group. You just need 2 groups. The age between Republicans and Democrats, perfect answers. So what you would look at is you go here to Republican, Democrat. There are ways to compare multiple groups. We use things like ANOVAs. It's not on Stat Tool 1. And then you would have right here usually box plots showing the visual display of it. But then you could compare the means because box plots are medians. Sometimes we put the mean in there as a star, and then you can look at the differences between the means. So this is going to be the age. And so once again, how many variables are being used here? Let me ask that. Type the amount of variables in a 2 sample t-test. And it's not the answer because it's a 2 sample t-test. There are 2 variables. There's age, and then there is political party right here. And it's not a 2-sample t-test because there's 2 variables. That's just coincidental. It's a 2-sample t-test because the categorical variable has what? Great job right there, Kristen. It's a 2-sample t-test because, and this is like, there's the 2 samples. There's 2 levels. Exactly. Does that make sense? So that's the 2-sample, and then it's a t-test because why? So it's a t-test because why? It's 2 samples because there's 2 groups we're comparing, and then it's a t-test because why? Because of means. Great job, Will, right there. So when you say the 2-sample t-test, you're like, okay, it's t, it's means. I'm looking at ages of people, and then we're comparing 2 groups, so it's 2 samples, 2 groups. Great job. So yes, no categorical variable, and 1 quant. Basically, it doesn't have to be yes, no, but it does have to be, let me pin that, Emma, 1,000 points right there. We'll 35,000, why not? It can be yes, no, but it has to have 2 groups. So yes, no works, but it can be other things like this right here is a 2-sample t. Does that make sense? But it has to be 2 groups for the 2-sample t. So a 2-sample t-test does not involve 2 quantitative. What would, a real quick question right here, what would be 2 quantitative variables? Does anyone know what, oh, Google? Hey, Google. Does anyone know what would be 2 quantitative variables? Got to know when's how we like that. Like, oh, what would be 2 quantitative variables like height and weight? What would be 2 quantitative variables? Q. Scatter plot. And what do we do with scatter plots? Regression, R squared, correlation. No, sorry. Sorry, Philip. Lines of best fit. Exactly. So 2 quantitative variables would be regression, lines of best fit, correlation, those ideas right there. So remember, the variable types are going to dictate what you have, and good stuff right there. Let's head back to the Kahoot. Here we go on the leaderboard. And good review, everyone. Good job. Fuzzy Dingo. Amazing. Wonder Kitten, Epic Crane, Great Dragon, Bold Leopard. Let's see who's going to win right here. Wow, it's amazing. Find the missing p-value. So you're missing the p-value for the what test? The greater than, the less than, or the does not equals test? You are missing the p-value for which of the tests? The greater than, less than, or the does not equals test? The less than. Great job, Jesse, right there. Oh, Jesse, 1,000 points. Throwing everyone points today, trying to give all the appreciation to everyone. So very important right here. Let's go take a screenshot of it. Always remember that p-values are probabilities. So that's kind of a hint right there if you're looking for p-values. They're all probabilities. And the does not equals has the absolute value. The greater than is to the right. The less than is to the left. We'll talk about how, well, I can kind of draw it out over here to the side. We're just going to call that 4% for the time being. The does not equals is 4% of the curve. The does not equals shades both sides. The does not equals shades both sides. And it reflects one on the other side. The greater than shades to the right of where you landed. The less than shades to the what of where you landed. And if this is 4%, and if this is 98%, this is 2%. Does it make more sense when I draw them out individually? It's basically, I rounded the numbers to make it a little bit easier. Does everyone understand the drawing on the screen right here? That the does not equals is what is the smallest value. The does not equals is what is the smallest. And you can see it right here. And then these two values, let me circle them, need to add up to what? Those two values need to add up to what? Nice job right there, Will. Your friend helped you out. We like that. The less than, the greater than need to add up to 1. So that's the good way to see it. And drawing it out a little bit more in depth can help out with this. This is where we use the applet a lot of times. But these values right here that I've circled have to add up to 1, because if you look, you're shading to the left and you're shading to the right. So you'll just shade 100% of the curve. Like if you add these two up, it would just be 100%. And then this is just a doubling of the other side over here when you do the does not equals. So pretty good work right there. It's about a 50-50, but knowing how to get the p-values on here is very important. The does not equals the greater than and the less than, and the does not equals says greater than absolute value. Nice work right there, Will. Here we go. Leaderboard's locked up. Bold Leopard in the lead. Next question. Make sure to email me if you win. Find the missing p-value again. So you're missing the what test. It is the same data, so if you're following along and remember it, you can get it pretty quickly. But you should know that the does not equals is just what the smallest. The does not equals is what, and Jesse has it right there. Great work, Jesse, right there. You're missing the does not equals, and it's double the smallest. Once again, it's the reflection on the other side of the screen. So when you look at your results right here, all you're doing, that's really cool. It just like pops up right there. You're looking at doubling it on the other side of the screen. So know which test you are doing. The greater than, the less than, those add up to 1, as you can see now. And then the does not equals is double the smallest. So good stuff right there. I do want to mention, before we move on, I want to mention other parts of this output. Let's talk about the other parts of this really, really briefly right here. And we're looking at differences in GPAs. So we're going to grab this output, bring it over to the other screen here for a second, and talk over this just for a moment. Okay, let's go look at the output right here. And, oh, there's the points. And let's go here to edit, copy, bring this over here, and take a look. How is the difference mathematically calculated? This difference right here is calculated how? So how is the difference mathematically calculated? Does the smallest... explain more detail, Will. And Sloan has the T ratio. Thank you for asking that, Will, right there. I'll try to go into greater detail. Sloan has the T ratio right here, which is Y bar male minus Y bar female over standard error of the difference. And so this is literally this value here. And then this value right here is this value. So if you didn't have the T statistic, how could you get this? This is on a Canvas content. So how could you get that value? Like, show me the mathematics right now to get that value. Like, try it right now. Try to solve mathematically for the T ratio with the math. Well, but put the numbers in and good work right there. I don't know. I don't think the difference is equal to that, Sloan. Oh no, it might be. But it's not the standard deviation, though. It's the standard error, technically. Great work right there, Jesse. And I got to throw 1,000 points. Great answers right there, both. Good work on it. And then plug in the values, as you can see right there in the chat. Plug in the values to show that you can solve it. It's just good practice to do it and be like, okay, wait. I just literally divide these numbers, and it gives me that value right there, because it's the difference divided by the standard error, which we literally have. But what does the lower and the upper interval tell you right here? Now, this is where you probably need to know how to what this. You're probably going to need to know how to what this. This is the 2-sample T formula right here, more in depth. It's Y bar 1 minus Y bar 2 over the standard error, which is S sub 1 squared over N sub 1 plus S sub 2 squared over N sub 2. And that's the standard error, and that's the difference in the means. And that's what you see right there. Does that make sense right there, Emma? So that is the formula for the T with degrees of freedom right there. So that is the formula. And this T right here is that T right there. Does that make sense, Emma? So the difference is the top component. That's the difference in the means highlighted in purple. The standard error can be abbreviated standard error of the difference. Yeah. And then the confidence interval is its own thing right there, which is totally different, and we need to know how to interpret it. So the interpretation of this confidence interval is, because we're comparing GPAs right here. Think about this. Since the interval is negative, which of these groups had a higher mean on average? The interval and the estimate are negative. So since they're all negative, which of those means was higher? Female. Does that make sense? If it's negative, it's the second mean is higher because that goes with the second mean. So females, we saw in our sample, had a GPA that was 0.05. We're just going to round it. 0.05 higher than males. Now I'm going to round all these things. We are 95% confident. I am 95% confident that the true difference between GPAs of males and females, and I'm rounding this, is contained in the interval 0.02 to 0.08 points, where females have on average higher GPAs than male. So remember, I am blank % confident that the true blank is contained in the interval blank to blank. And then I mentioned that it's that females have higher GPAs than males. And so we would have good evidence to believe. And also think about this. Why do we also have good evidence to believe that females have higher GPAs than males? Sorry, males, I didn't help out. Why do we have good evidence to believe? And look if you put the greater than up here. If you go male less than female, which is the sign of the sign. If you go that, look at this. Why do you have good evidence? 0 is not in the interval, and also you what the what. So 0 is not in the interval, low p-value, you'd reject the null and say you have evidence for the alternative. So not only do we have, and you could do it for the two-sided too if you wanted to see if there is a difference, but we do have evidence that the female GPA was higher than the male GPA on the true difference right there. But here's the thing, this is the last thing I'll say. You might argue that this difference is really not that much what? Ooh, I would throw 10,000 points if anyone knows what I want to hear here. You might argue that this difference, someone might argue it. Yeah, good question, Kristen, right there. So it is statistically significant, but you might argue it might not be that what? 320 might hop in and say the answer. It is statistically significant, which, boom, Jesse said it right there. And Lane said it, practically significant. But I mean, hey, would you take 0.02 points on your GPA? I'll take any points on my GPA. But probably not that practically significant because it's a very small difference. It's like, it's still unlikely by random chance. Maybe it's due to our large sample size shown kind of by the degrees of freedom. Like degrees of freedom are not going to tell you the exact sample size, but degrees of freedom are kind of created around sample size. So good work right there. Let's hop back to the Kahoot. It is a difference. It's a difference that's unlikely by random chance. So there's something going on. Probably me. Next question. Here we go. Bold, Leopard, Stone, Lead, Epic, Crane, Fuzzy, Dingo. Here we go. Next question. What is the missing T ratio? What is it? Try to do some quick math if you're solving this. Do some quick math. You can get it super quick. Type yes in the chat if you got this with quick math super quick. I picked this one for a reason. You got it, Sloan? Yep. You're like, well, wait, how? Remember that the T ratio is found how? What do you need to do to find the T ratio mathematically? You might still have the picture up. How do you get the T? Well, that's not the right one. How do you, and then great job, Kristen, right there. Nice job. Replacing the pin message right there. The T ratio is the difference divided by the standard error. So just knowing what the formula you're doing is, I'm throwing 5,000 points for that. Yep. And Jesse's showing the mathematics right there. Elizabeth is also talking about the difference divided by the standard error. So what do you notice about those numbers? Well, first off, the T ratio must be what? And you can actually see the T ratio down there. So you can, and that's actually the difference, but it also leads to the T ratio must be what? The T ratio must be what? Just look at this visually and understand over here, it must be negative because it's some number divided by some number, the top number is negative. So that eliminates it down to here and to here. But think about this, you're basically just whatting the decimal. So when you look at these two numbers, the difference is almost a factor of 10. And boom, there's the answer right there. So if you look at it, you're like, oh, that's yeah. Moving the decimals. And think about this. If the T ratio is basically negative 10, why do you think the p-value is so small? The area to the left of here is basically what? Which it's telling you with this answer right here. The area to the left of that mark is basically what? To the left, it's basically nothing. So this difference right here that we see is super unlikely by random chance. Like this difference right here is like, yeah, this is really strong. I'm trying to remember what I analyzed here, but this is very strong evidence of a difference. I think this was a different data set for GPA, and this is a much stronger evidence that there's a difference in GPAs right here with this data. And great work, everyone. Arista, great work too. Elizabeth, Kristen, Abby, Carly, Jesse, Sloan, John, Emma, excellent work. Let's do the next question right here. Here we go with the leaderboard locked in place. Let's do it. Oh, Colin, good to see you here. Let's throw 5,000 points for Colin showing up. What is the missing difference? Dun, dun, dun. If you're paying attention, and I think we had Jesse explaining, or no, Sloan was explaining how to do this. So the difference right here, the T ratio is the what of these two values. It's just more memorizing this, making sure you get it down. The T ratio is the what of those two values. Well, it's literally telling you what it is. The t this, which is the t statistic, is the what of those two values. The t is the what of those two values. It's the ratio. And you can see that if you go and look at the equation right here, that you're literally taking the ratio of these two numbers. So it's the ratio. And I think Sloan showed it right there how to do it. And then just understanding that t is a ratio of the two numbers. And this is negative 10 times that. So you can just take, and we don't usually solve in reverse, but it's just kind of good to know that negative 10 times that would be this. And the t ratio is showing it to you right there. And yeah, I forgot the negative, but make sure to do the negative right there. Yeah, show up to class level achieved. Nice job, Will. Yeah, we're throwing some big points out here. I'm still not there. Don't worry, Abby. If you have any questions, let us know. And great job, Ellie, right there. Lots of good answers. Here we go. We'll do some new questions here. Leaderboard locked up. Let's do it. What is the null hypothesis for this test? So what's the easiest way to remember how to do the null? What is the easiest way to do the null? We'll throw more points. The null has the equal sign. So the first thing that we're doing is what we are testing. Say it with me. We are testing the what between two whats. Can you fill in that sentence? This is a test of the what between two whats. The two sample t-test is a test of the what between two what. The difference between two means. We want to understand the true difference. Great job right there, Sarah and Jesse. So we want to understand the true difference between two means. So with that, we are asking, is the true difference between the means what? I'm asking, is the real difference between male and female GPAs what? Think about how the sentence would read. Is the true difference between male and female GPAs what? How would it read? Is the true difference between male and female GPAs what? Is the true difference between male and female GPAs what? How would the rest of the sentence go? We're wondering if the true difference between male and female GPAs is what? Is it 0? Well, that basically, Kendall, that's correct. Is it equal to 0? And what are you basically saying? When you write this right here, you're basically saying that males and females GPAs are what's. The null hypothesis for the two sample t, great job, Vaughn, right there, is the exactly. Think about reading it as a sentence. When we take the difference between males and females GPAs, because that's what we're testing, male minus female, just put male, female right there. When we take the difference of male minus female GPAs, is it equal to 0? And Abby said it so well. We're seeing if it's the same, because you can go here and look at the algebra of it. And if you algebra this out, you just take right here and do mu male minus mu female. And then you do equals 0. Well, you can just say mu male equals mu female. And that's the same thing. Like, are the two means equal? Or, so this would say the two means are equal. This would say they have no difference. It doesn't matter. Same tomato, tomato right there. Tops Bama games. How can you tell when it's not equal? Well, so when we do the alternative, so this is the null, and I prefer to write the null this way. It's the researcher question that determines the what of the alternative. It's the researcher's question that determines the what of the alternative. So we do mu male minus mu female. The sign, great job. So the researcher is going to say, well, maybe I want to see if they're not equal to each other. Maybe we'll see if males have greater GPAs. You could literally just put it right there. That's one way to see if it's right, like, because it'll be positive if males have higher GPAs. You could test that or that. Now, you don't run all three, so don't write it this way, but you could determine which sign to use. And the only thing, so say it once again here, the only thing that changes when you write the alternative is your what? The only thing that changes when you write the alternative is the what? The sign. The only thing you change is the sign. And the sign is going to indicate what you're testing. The null has the equal sign, and then the alternative is based on what you're investigating and what you're looking for evidence of. So you can literally take your null and just change the sign, but then try to read it as a sentence. We always say do that. We are looking at the difference between males and females GPAs, and we believe that that difference is equal to 0. We are looking to see if there is evidence that the difference between males and female GPAs is not equal to 0. Reading it as a sentence is going to be the key to understand what you're writing. And just, I mean, think about, if someone doesn't know stats, could I say, I'm looking to see if males and females have a different average GPAs? Like, are they different or are they the same? Would people understand that who don't know stats? Like, looking at males and females and seeing if there's a difference in their GPAs on average. I'd say, yeah, people should, oh, you want to compare males and females, look at their GPAs on average? Okay. And then this is how we write it mathematically. So think about talking to people and what they would understand as you say it. Like, if it doesn't make sense when you say it, be like, I don't know if I'm saying the right thing. Great work right there, everybody. Which one are you confused on, Emma? We'll pause here for another moment. Let me know. What are you wondering, Emma? I'll put a full thing. Once again, we're here to learn. Please ask any questions. I might go on in a moment, but please put any questions you have in the chat. We want to explain everything fully. Why would this be less than 0 since it's negative? So it just depends on how you want to test it. And I think one way to write it out easier for people a lot of times is you can write out here. This is still mathematically equivalent. If you write it this way, that would say males and females have equal GPAs. And then here you could say that the difference is that males have a lower GPA than females on average. Now, this is the equivalent, I'm just writing an equivalent statement, of saying if we look at the what between males and females, what is this right here that I'm writing? I'm looking at the what between males and females. What is that looking at right there? That is looking at the what between males and females. What I've circled. The difference. Does that make sense? That's the difference. And if the difference is less than 0, it would have to be because females had a what GPA to males. If the difference is less than 0, it has to be because females have a true GPA that is what are to males. If the difference is less than 0, higher. Does that make sense? So mathematically speaking, and we're just plugging in fake numbers, if females had like a 3.8 and males had a 3.7, this would lead to a negative difference right here. So we're analyzing the difference. This is an equivalent statement right here to say that we're looking for evidence that males have lower GPAs. This is for a particular example. Exactly. If someone wanted to investigate that males have lower GPAs than females, this is the alternative they would run. And these are two ways of writing it. Both of these statements are identical to say that the true mean of males is less than the true mean of females, or the difference between males and females GPAs is less than 0. Both of these, you don't have to write both. It's just two ways of writing it right there. Does that make sense, Emma? Both of those, we wouldn't write both of them. We would just write it out one way, but this is equivalent to write the alternative that way. So we'd probably just write it like this. So really good questions. Emma, let's throw Emma 10,000 points. Please ask all those questions because I want everything to make sense, and explaining things different ways can really help people, I think. I always try to do it different ways. You're welcome, Emma. Thank you for asking. We're here to answer questions. Time for the next question to answer, for you to answer. Let's do this right here. Bold Leopard still in the lead. Next question. What is the alternative hypothesis for the two-sided test? So it's very important we know what a two-sided test are. This is a weird question to ask, but how many two-sided alternatives are there? The null always has the equal sign when we write out with notation. We do the independent, but that's when we do the chi-squared. There is one two-sided test, and this is going to sound crazy. How many one-sided tests are there? It sounds crazy as I'm saying this. There's one two-sided test, and there's two one-sided tests. And we actually still have them on the screen right here. So what we're talking about is this particular area right here. Now, the reason it's called two-sided is because we shade both sides of it. So these are the one-sided alternatives known as the what or the what test. The one-sided alternatives are known as the what or the what test. Like you've got the answer over here. The one-sided alternatives are known as the what or the what test. So those are one-sided. They shade one side of the curve. Don't confuse them with a one-sample t-test, though. Greater than or less than. So when you do greater than or less than, that's one side of the curve shaded. Those are not one-sample t's. This is a two-sample t-test because there's two groups we are comparing. So these are the two samples, but then we could do the two-sided alternative, which is a different idea. The two-sided alternatives is the does not equals, which shades both sides. So there it is right there. Good work on that one. But remember, and this is a key thing right here, two samples refers to you're comparing what? two whats. Two samples tells you you're comparing two whats. Two samples tells you you're comparing two whats. Like when I say a two-sample t-test, two means. Two-sided means the sign of the alternative is the does not equals. So sidedness of a test relates to the alternative sign, where samples means how many groups there are. Like I have a sample here and a sample here, two groups. Good work, everybody. Here we go. Leaderboard is locked up. Who knows what's going to happen? Next question. Interpret the difference. Good stuff. First thing to notice is the difference positive or negative? The difference is what? First thing to notice when interpret, it's negative. So that's indication that the second something is higher. Now we're doing a t-test. If we're doing t's, we're comparing whats. If we're doing t's, we're comparing whats. And this is, once again, us hammering it down, make sure we know it. We're comparing means. So this would be evidence that the second mean was higher than the first mean in the sample. So we have the mean for females, which is the second mean, is, and that's the difference. The mean for females is this much higher than the mean for males, the mean for men right there. So good work if you got it. Remember, T means mean. We're doing the t-test, and females is higher. So good work if you got it. Pretty good work right there. Pretty good answers. Let's continue on. Woo! Bold leopard, epic crane, fuzzy dingo, wonder kitten, great dragon. Let's see who's going to win right here. Storytime type 1 error, it's a twig. So you're walking through the woods right here. You know that most things in the woods are a twig. So you're thinking, you know what? Everything around me is a twig. But oh no, you make a type 1 error. So say it with me if you haven't. I'm going to give you until 90 seconds before I appear on the screen for you to figure it out. Your null hypothesis is that it's a twig. So what does a type 1 error mean? False positive. Emma, good work right there. Let's throw Emma another 1,000 points right there. And I'm about to appear on the screen and explain this, and we're going to pin Jesse's message. 5,000 points for Emma and Jesse, giving some great answers right there to start. So here's what we have to do. So I'm going to block some answers. In a type 1 error, and Jesse put it right there, the null is true. So everyone see that. This is the way you can memorize it, and you're not cheating if you do this on the test. In a type 1 error, the null is true. Well, that kind of just figured out the problem. When we say the null is true, what's that mean? We kind of just figured this out. We'll continue the rest of it. In a type 1 error, the null is true. So what's that mean? Just think about what that means right here. Okay, so whatever this is, that thing right there, you're looking at it, that's a twig. It's true. But we what it? In a type 1 error, the null is true, but we reject it. So what are you mentally going to do? You're going to reject the true null. So it is a twig. It really is. But you are going to what? What does that mean? What does it mean that you reject it? Sheena said it right there. You think it's a snake. Sheena, let me give Sheena 5,000 points. Great work right there. So you think it's a snake. So let me see. I might be blocking the right answer. Oh, I'm not blocking the right answer. We run away because we think it's a snake. So that's a type 1 error right there, a false positive, which is a great way of thinking about it. So make sure you say, okay, in a type 1 error, the null is true, but I reject it. So we just did type 1 error. Take a wild guess at what we're going to do next. But notice, and I want to point this out, this is almost right here a what? 31 to 21, not quite. The answers right here are almost a what. And I do want to point this out. So do these very slowly. Don't answer, unless you're certain, don't answer the next one until maybe 60 seconds in, because there's another story time coming up. It's almost 50-50. So walk through this very slowly with me. If you don't know it, we'll practice it right here. We're about to do type 2 error. Let's go to leaderboard. We might have a leaderboard shakeup. Oh, leaderboard's locked in. Let's do it. Type 2 error. You can answer anytime you want, but here we go. I'm going to disappear off the screen and give you a little bit of help right here. The null hypothesis is that the tree is healthy. That is the null. So when you think about the type 2 error right here, in a type 1 error, the null is true. I'm going to appear on the screen in 90 seconds. And we reject it. In a type 2 error, the null is false, and we fail to reject it. In a type 2 error, the null is false, and we fail to reject it. Okay, got a lot of people answering. I don't want to skip it. Let me go off that. Okay, I'm going to appear on the screen. Okay. In a type 2 error, the null is false. So you have to look at this and say what? We got 90 seconds. Help me out right here. You have to look at that and say what? That is what? Like, and then tell me what that means. Jesse's got it right there. In type 2 error, the null is false and we failed to reject. So what does that mean? Tell me about it. That is correct. So what does that all mean? There we go. The tree. So that is a fact right there. You've just told me a fact. The null is false. The tree is not healthy. That's a fact of the world. But you are going to what? You're going to not reject the tree being healthy. So if someone looks at a tree and says, I don't reject that tree is healthy, what are they going to do? I think Vaughn sees it. Someone looks at a tree and they go, not that tree right there. Correct. You would continue to believe it's healthy, right? But the tree, is it healthy? Is the tree healthy? The null is false, right? We're just repeating ourselves a little bit here, right? And I think Courtney's seeing it too. Well, yeah, still sees it. So we think it's healthy even though it's not, because we don't reject the null. We fail to reject the null. And remember this, in a type 2 error, the null is false and we fail to reject it. These are Fs for the type 2 and there's 2 Fs. Great job, Abby, right there. And I think people see it. Am I blocking the right answer? Well, I did block the right answer, so that's why I only appeared at 90 seconds or so. You leave the tree up and it falls. Great work. Let's throw some 10,000 points. We got a lot more answers correct right here. So that's what we like to see. Do these types of things very slowly with type 1, type 2 error. Do remember the things that go into type 2 error, which is going to be sample size, is going to be effect size, is going to be your alpha level. False, and we fail to reject type 2 is great job right there, Courtney. No, I'm very happy with that right there. Going crazy with the points, as we often do at the end of the semester. Leaderboard is so close. Here we go with the next question. Let's do it. When doing a 2-sample T, the variables will be what? Ooh. At each 15 seconds, I'll eliminate an answer. Yeah, Jacqueline, it's good practice right there, though. 2 categorical variables is chi-square test of independence. Things like let's analyze gender and whether or not people are married. Sure. So that would be mosaic plots, contingency tables, 2 categorical variables right there. That is not 2-sample t-test. Both quantitative variables. If you have both quantitative variables, that's going to be a regression because QQ straight enough, no outliers, plot doesn't thicken. So you're doing regression, quantitative scatter plots, exactly correlation. So that's 2 quantitative variables like looking at height, weight, hours studied, GPA, all those things, 2 quantitative variables. So what about this? Well, here's something we don't usually use: identifiers. Identifiers are actually categorical variables, so it kind of would do a mosaic plot again, but this would not be a good idea. This is generally a bad idea because identifiers are used to identify. Sloan's got it right there for 1,000 points. Great job, Sloan, right there. Let's throw you 5,000. Why not? And so the answer is right there, and great work.
Wow.
Got a big compare wow on that. Awesome work right there. 1 categorical variable and 1 quantitative. And what graphic would you get for this? What graphic would you be looking at for this? Actually, yep, here we go. The graphic for analyzing it is often a what? What graphic do we often have to analyze a 2-sample T? The 2-sample T, you often see it analyzed with side-by-side box plots right there. And if you don't have this, take a picture of the all graphics right here. You can see side-by-side box plots over there. I think I can put on the same time. Categorical X, quantitative Y right there. So you can see all the combinations. This is a pretty good graphic for tools and techniques. You can see where scatter plots are. You can see bar charts, pie charts. Now, why over there? People might wonder, why is there nothing over here on the X variable for histograms, box plot, singular histogram, singular box plot, singular stem and leaf, singular bar chart, singular pie chart? Why is there nothing over here on the other variable? The Y variable is what we want to understand. They're univariate. Great job, Maya, right there. We're throwing Maya some 5,000 points. All those answers today. Great job. They're univariate. So those are univariate graphics. There is no second variable. These are the bivariate combinations. If you didn't notice it, they're also color-coded where blue are only quantitative, green are only categorical, and the ones that are black are a combination. We don't do logistic regression in this class, but check out earlier today where I was doing the 320 review if you want to see some logistic regression. So good stuff right there. And let's see how the Kahoot's doing. Leaderboard time. My gosh, it is close. Let's see who's going to win right here. A few more questions. 3 more to go. When working with statistical power, which of the following do we have the most control over? most control over? Which one of these do we have the most control over? Scary, right? Well, let's eliminate one answer for certain. You ready? What is a wrong answer here? What is a wrong answer? Beta. No worries. Beta, and I might go and review this on another screen in a second. Beta is going to be the probability of what? What is beta mathematically? Like, what does it tell us? I'm trying to remember if I put 2 correct answers. This is going to be scary. This might shake up the leaderboard if I didn't put 2 correct answers. I am literally going to give Sloan 10,000 points for the class. And if anyone gets this wrong, loses their streak. Remember, you got 10,000 points for Sloan saying that. Beta is the probability of a type 2 error. It literally is type 2 error. Effect size is the true difference between the null and the alternative. Like, think of it as like, if Brian says he can run a 6-minute mile, but I really run 8-minute miles, then the effect size is 2 minutes, like the true difference between the null and the truth. And then sample size is how much data we collect, and alpha is going to be the point at which we reject the null, and that is something we can change at any time. And Sloan, you were right. And if I did put one answer, which one of these would it be? If Brian did put only one answer, which one would it be? And this would have been crazy. Which one of these do we actually have the most control over? I wouldn't put sample size. Now, you do control how much of your sample you take. Can you change? If you change your sample size, you'd have to go collect more data. You do control that, how much data you collect. But alpha is just whatever you want it to be. Yeah, I was a little bit scared. I was ready for some people to lose their streak if I only put one answer. Because alpha, how easily can I change alpha? If I'm a researcher, how easily can I change alpha? And Kendall said it right there. Can I say alpha is 0.01? Like, could I just write in my research paper, like I'm writing a research paper and I'm like, we used an alpha of 0.01. Can I write that? Yep. Can I just all of a sudden go, we sampled 500 and go, no, let's sample 800. Can I just change sample size? I mean, I can change the number, but then I actually would have had to create that sample size. So the alpha is whatever you want it to be. It's assumed to be 0.05 unless otherwise stated. And let's write this down real quick for everyone studying with this. Here's an important thing to know. Type 1 error is actually your what? Like, mathematically speaking, the probability of making a type 1 error is what? What is the mathematical probability of making a type 1 error? Boom, Sheena right there. I thought I was going to have to give more hints. Let's throw 10,000 points for Sheena right there. We're throwing some big points at the end for everyone still watching. That is the exact answer I was looking for. Great job, Sheena right there. Yes, it is alpha. And type 2 error rate is what? Type 2 error rate is what? Well, we just said it a moment ago, right? Type 2 error rate is what? It's easy to remember, like 1, 2, A, B, and then you can remember positive, negative. That type 1 is kind of considered a false positive and type 2 is considered a false negative. So it's a good way to memorize it to think like type 1, type 2, alpha, beta. But here's the thing that you need to know. Are these two values complements? Is it true that like 1 minus beta, is that equal to alpha? Is that a truth right there? 1 minus beta equals alpha. Well, Sloan's already there. Sloan some points in the chat. Because 1 minus beta is not alpha. Sloan's already said it. Just think for a moment, what is 1 minus beta finding? It's everything but making a what? So power of a test, power is the ability to correctly reject the false null. That's like the textbook. But power is that your test will not do a what? Because think what it's doing mathematically. Power is when your test is not going to make what's. You do need to know this. That is, you do need to know that. Power is what? It'll not make type 2 errors. And a type 2 error is when you fail to reject the false null. So when a test is powerful, it will do what? Think about this. If a test is powerful and it won't fail to reject the false null, it will actually do what? So in textbook, we got the textbook there. So if a powerful test will not fail to reject the false null, it will not make type 2 errors, it will reject the null when it's false. Does that make sense? A powerful test will reject the null when it's false because it's 1 minus, which is the complement of it's 1 minus the false negative. So it won't make false negatives. It will find results when results exist. Does anyone feel like they understand power a little bit more? Like power is the ability to correctly reject the false null. And just to review real briefly on this, power is controlled by 3 things: sample size, effect size, and also your alpha, which all 3 of these, if you increase them, will decrease beta. And power is 1 minus beta. And we've written this out in class too, but it's important to know these little concepts right here. So these increasing make beta smaller, but power is literally 1 minus beta. So if you get a bigger sample, your test will be more what? If you get a bigger sample, your test will be more what? Power is the ability to correctly reject the false null. Let me, Sloan had it right here. I'm going to pin Sloan's message. If you get a bigger sample, you will what? It'll be more powerful. If there's a bigger effect size, it'll be more powerful. If you have a higher alpha, it'll be more powerful. But the one we really control right here would be probably this first, this second, but you don't control the effect size. The effect size is the true difference between the null and the truth. So you don't really control what the difference is that you're testing, but if there is a bigger difference, the test will be able to pick up on that difference a little bit easier. And once again, make sure to review. We've got a lot of videos going over this. This is just a small review here, but here we are at the leaderboard. Oh my gosh, Great Dragon. Who's gonna win? You ready for the last question? Let's do, 2 more questions. Calculate the degrees of freedom right here for freshman, sophomore, junior, senior, and owning a bunny. Yes, no. Review question from the past, but we gotta have a cute bunny in there. That's not a mini Rex or a New Zealand white. Best bunnies ever. So you would say to me, Brian, that's a what by what? Review questions from the start. Brian, that's a what by what? So right here, you got to look. Brian, that's a what? That is a 4 by 2. And whichever way you do it, it doesn't matter which way you do it. So if it's a 4 by 2, what do you do? 4 by 2. And Anthony's got it right there. 4 by 2. There you go. So people might have it already. 3 times 1. What kind of test would you run on this? This is a review now. We're going to go through the rest of this. Just remembering would be that owning a bunny is independent of what class level you are. Movie Rex, Donnie Darko, Eternal Sunshine of the Spotless Mind, and then Spider-Verse. Watch those if you haven't. So Donnie Darko, Eternal Sunshine of the Spotless Mind, Spider-Verse, good recent movie right there. Good stuff. Spider-Verse is awesome. Get ready for the new Spider-Man movie, Across the Spider-Verse. Really excited about that. Looks absolutely insane. And then go watch some classics like Donnie Darko. Don't watch the new Darko film. New Spider-Verse is going to be absolutely insane. Spider-Man's the best superhero. Batman 2, the new Batman movie coming out, or new Flash Batman movie. Spider-Man 2099 looks wicked. Besides Captain America, have you watched what is GOG? What is Game of Thrones? What is GOTG3? What is that again? I feel like I know that, but it almost looks like Game of Thrones. What is that right there? I haven't seen Guardians of the Galaxy 3 yet. No, I haven't seen it. Yeah, Donnie Darko and Eternal Sunshine. Eternal Sunshine is easily one of my top favorite movies of all times. Or Gattaca. Watch Gattaca. Gosh, I saw Gattaca in high school. You're like, really? And I'm like, oh gosh, yeah. So watch Gattaca. That's a good film right there too. Ethan Hawke, Jude Law, and Emma Thompson? I don't know. New Transformers too. Fun stuff. First Transformers. Oh my gosh. I'm gonna give one last shout out here. My one of my friends, Cody, his cousin is Megan Fox, and I met Megan Fox's grandfather because I went over to see Cody's grandparents, and I meet him. He's like, "Hi, I'm Fox, like rabbit," and that's the first thing he said to me. I'm Fox, like rabbit. So he'd go by Fox. That was his last name, so he went by Fox. I don't know his first name. Really nice guy. He sadly passed away, but it was nice. Cody just happened to be like, oh yeah, my cousin's Megan Fox. And I was like, oh, cool. So you never know. Shouts to my friend Cody right there. But with that, let's do the last question of the day right here. You never know. You make a bunch of friends. Sometimes your friend's like, oh, this is my cousin. You're like, oh, neat. Next question right here. Last question of the day. Here we go. Let's do it. How could someone make this test more powerful? Ooh, what do we got right here? A little bit of a trick. A lot of time. This is power. Once again, power is the ability to correctly reject the false null. Power is not making a type 2 error. Now, yes, there is a theoretical answer here that works, but that's not really how we do it. So when you think about power, I'm going to go to a different screen here at 70 seconds. Oh, no, Emma. No. Yes, alpha does control power. But Emma saw it. Emma, because alpha is what with power? Alpha is what? Whatly correlated with power. Alpha is whatly correlated with power. So we got the graphic right here. Oh, it's not negatively, not negatively. Alpha is positively correlated. So if you were to decrease, oh, no. It's not inversely, it's directly. If you increase alpha, this is why I've got it color coded here. If you increase alpha, you increase power. Does that make sense? If you increase sample size, you increase power. If you decrease alpha, you decrease power. If you increase alpha, you what beta. If you increase alpha, you what beta. And I'll go back to the screen over here. So that's what that graphic's read. So if you increase alpha, you decrease beta. But beta is, well, 1 minus beta is power. So increase alpha, decrease beta, increase power. Because power is 1 minus beta. Does that make sense? So make sure to have those notes. Make sure to understand what they mean. So 1 minus beta right here. This is yes, but no. That's you don't increase power by increasing power. That is power. So you don't increase power by increasing power because that's tautological. Decrease effect size, no. The only one right here is increase sample size. No, it's all right. Good work. This is good practice. Think about this, and we're gonna have Tiny Brian come on here to give the announcements. But when would you say a test is powerful? If you took a bigger sample or a smaller sample? Like if you want to make a really powerful test that could find your results, you would take a big sample or a small sample? A bigger sample, and that's when a test is more powerful and it can find results. Power is the ability to correctly reject the false null, but then remember, it's the ability to find results if results exist. So if you have a powerful test, you can find results. And great job, Maya, right there. We got fan favorite Tiny Brian right here. Where are you at?
Tiny. No, is that my voice? I think, no, that's me, bot.
Tiny Brian. Woo, there we go. Woo, thank you. Don't give me Meebot's voice. Here we go, everyone. Let's do this. In third place, we have... Hey, Jacqueline, good to see you there. Oh my god, Einstein is a bear? Fuzzy Dingo! I heard Brian tried to remove you from the leaderboard. Epic Crane, and number 1 being... Bold Leopard. Make sure to email Brian. Great job. Tiny Brian out.
Tiny Brian sounded like Mewbot there for a moment. Sloan, were you Fuzzy Dingo and you got back on the leaderboard? That is insanity. And you know what we might do? If you want to hang out for a moment longer, we could try Tallest Towers if people want. Who would like to do a review? I'm going to do a 5-minute thing right here, and I might even play on a team. Some of the output might be hard to read. I did not configure this, but we're going to try a new thing right here. If you want to hang out for a moment, we're going to try the Tallest Towers game. So if you want, you're welcome, Emma, right here. I'm going to see this. I'm kind of experimenting with what's possible. They've got all these new buttons. So the only way to do this is to just try it. So let's give this a shot right here if you want. And thank you, everyone, for being here. We're going to try Tallest Towers. So if you want, this is a game where you build towers. I want your thoughts on this if you like it or don't like it. So I'm going to join in right here and I want to see how it works. We've tried it in the other one, and I might even try some of the other games. But I'm going to log on to Kahoot.it and play with a team. There's no points for this one. You're welcome, Sarah, right there. I want your thoughts on this, though, if you like it. If you're like, hey, that was pretty cool, or nah, I don't like that so much. So we're going to start here in just a second. I think it's going to be basically the same questions. It's not really formatted correctly, but get ready. I want to know your thoughts on this. So here we go. Starting in 3, 2, 1. Let's do this. So you're going to answer questions and then click on where to lay your tower. So it's a little bit of a game, and it's also the questions that I have. It might be very hard to see some of the answers. This is not formatted properly for this. Just kind of want to know your thoughts. And here we go right here. Let's give it a shot. Drop your towers. Okay. Also, I can't really comment on it other than like telling you what's going on. So let's play it and see what people think about this. You're welcome, Nick. Okay, we're playing. I know all the answers. My team's gonna have a huge advantage. Uh-oh, here we go. We got towers dropping. I'm on Sunshine Team. Come on, Sunshine Team. Oh, it's gonna be so interesting. I want to see who wins. And then you can tell me your thoughts on it afterwards. Monster incoming. Oh no. It's very hard to see some of the graphics. Ooh, I got a question wrong. Oh my gosh. Did we beat the monster? I think we did. Woo! Oh, they got a monster on the screen. I'm trying to memorize all my answers. I gotta get 5 questions right. Tell me your thoughts after this, after you play it. Like, dislike. I want to look at more game types. Ooh. Oh my, do they have 8 over there? I'm gonna be on the losing team. The teacher's gonna be on the losing team. Got a monster on my screen. Oh gosh. Darn it. The math ones are not fun. Good. Got an easy math one. I don't have a calculator in front of me. Oh my gosh, team on the left is going crazy. Oh jeez. He's giving me that one because I didn't get it. I can see it. Oh, there's 2. Oh, well, good. Oh no. I think it gives you answers you miss more often. Oh my gosh. Team on the left is destroying. How in the world? Oh, dang it. Whoops, missed something right there. Wow. What do you, if you're in the chat still, what do you think of this? What do you think? My team lost. That was woo. It was fun, Jesse. I kind of liked it too. I need to formulate better questions. I was lively elk. We did a good job, team. Who was adorable snail, and who was whoa, that whole team over there. Who was bold leopard, honest meerkat, and epic bison? Yeah, you might look at the yeah, it looks like people thought it was kind of fun. I need to look at bold leopard. Who was Jesse? Jesse, you literally almost... I wrote these questions. Your score is right about at mine. That's pretty crazy right there. So amazing work. I mean, you almost... That is nuts. That is absolutely... Oh, no. You did really good over here, team. But great work, everybody. Maybe we'll try to do these other games. I need to formulate some other questions. But my gosh, that fire team was absolutely on fire. Team Fire is goated right there. I know. Like, they didn't have first place player. I'm just saying that right there. But really cool. There's other games to play also, but I just kind of wanted to check this out. Seems like people did have some fun with this, so maybe we'll look into other game types, and I would probably need to come up with some other questions, but this might be fun to do, and it's kind of your own individual learning then. And yeah, some of the questions just really don't format for it though. So yeah, good stuff right here. High pressure, right? But it was like, we probably just did 10 minutes of reviewing, and it was actually kind of a little bit more fun. So you know what I might try to do? I might even make, we'll see, maybe like Monday night or something, I'll do one of these and we'll play the games, and we'll maybe look at all the different games and play different versions of them, see which ones we like to use. Would people like that? We'll do like just fun review game nights. Maybe we'll look into it, and I'll have to write some new questions. That'd be fun. And then especially maybe if people want to help write questions, we'll look into it. Yeah, awesome. Well, and so thank you everyone here playing this. Really good work. Well, until then, bye for now, everybody. Bye.